All right, so this is Wednesday's assignment on Charles' Law. Number 1, a sample of air has a volume of 140 milliliters at 67 degrees Celsius. At what temperature would its volume be 50 milliliters at constant pressure? Okay, so we have a volume, V1, and that's 140 milliliters. And that temperature, T1, is at 67 degrees Celsius. Now the question asks, what would the temperature be? So we're solving for T2. If the volume is, V2 is 50 degrees, I said 50 degrees, 50 milliliters, 50 milliliters, right? So remember, we have to convert Celsius into Kelvin. I'm going to add 273. So 67 plus 273 is 340 Kelvin, right? Now we plug in our values. This is Charles' Law, is right here at the top to remind me. 140 milliliters over 340 Kelvin equals to 50 milliliters over T2. Okay, so I'm going to multiply that and multiply those numbers. I'm going to write over here. So we have 140 times T2 equals 340 times 50. So this side stays 140 T2. And on the right side, we have, I didn't even do the multiplication. So 340 times 50, we have 17,000. Then we divide both sides by 140 to get T2 by itself. And then we will know that T2 is 121 Kelvin. So you stop here. I saw some people, they would add 273 against that. No, because it's already in Kelvin, okay? So you don't have to add 273 already, okay? So that's number 1. Number 2. A man heats a balloon in the oven. Why would you heat a balloon in the oven? Okay. If the balloon initially has a volume, so initial V1, 0.4 liters, and a temperature, T1, of 20 degrees Celsius, the question asks, what would the volume of the balloon be? So we're looking for V2. If the temperature increased to 250 degrees Celsius. Again, I'm going to convert Celsius to Kelvin by adding 273 on both sides. So 20 plus 273. $293 Kelvin, and then 250 plus 273, 523 Kelvin. Now I have all my values. And I'm going to plug it into the formula. V1, 0.4 liters over 293 Kelvin equals V2 over 523 Kelvin, right? I multiply those two, multiply that. 0.4 times 523 equals 293 V2. I multiply on this side, 0.4 times 0.4 times 523. Ooh. Hold on. 523 times 0.4, making sure my math is right. Okay, so I have 209.2 equals 293 V2. Now I divide both sides by 293 to get V2 by itself. And if my calculations are right, our final volume should be 0.7. The units is liters. Okay, 0.7 liters. All right, moving on to number 3. A helium balloon in a closed car occupies a volume, V1, 2.32, what's the units? Liters. The temperature T1 at 40 degrees Celsius. If the car is parked on a hot day and the temperature inside rises, so T2 rises to 75 degrees Celsius, what would the new volume be? V2. Okay, I'm adding 273 to convert this to Kelvin. Once again, so T1, 313 Kelvin, T2, 348 Kelvin. Plug in my values, 2.32 liters over 313 Kelvin equals V2 over 348 Kelvin. Multiply those two numbers, 2.32 times 348 equals 313 V2. And then V2, the final volume should be 2.6 liters. Okay. Moving on to number 4 and final number. A sample of neon gas has a volume, V1, 752 milliliters at 25 degrees Celsius. What would the volume be? So we saw for V2 if the temperature increased to 100 degrees Celsius. Again, convert to Kelvin. We have 298 K for T1, and in T2 we have 373 Kelvin. You plug it in, and then your final volume, you should get 941 milliliters. Okay, please double check your answers. If you got a 3 out of 4, 2 out of 4, do it over. You have the answers right here. Get the full credit. Any questions, you could write me on Jupiter.